Okay, so we're going to do a review of applying the first derivative test. And the question's going to say, find the relative extrema, and then they're going to give you a function. Okay, so first off, the first derivative test tells us that if the slope goes from being a positive value to being a negative value, at this point, I will have a relative maximum. Likewise, if the slope goes from a negative slope to a positive slope, I'll have a relative minimum. And if there's no change in the signs, then I won't have a relative minimum or a maximum. All right, so we're going to write the function f of x equals 2x to the third minus 3x squared minus 36x plus 14. All right, so I have to find the first derivative. So the derivative is denoted by f prime of x. Okay, so to find the derivative, I'm going to drop the exponent. Those numbers get multiplied, and then subtract 1 from the exponent. This is going to give me x to the 0, which I'm not going to write, and the derivative of the constant is 0, so that just goes away. All right, so here's my derivative. Now, I need to find my critical numbers. To find my critical numbers, I take my derivative, I'm going to set it equal to 0, and I'm going to solve it. There's a 3 in common, a 6 in common, so I'm going to take the 6 out. And then I'm looking for factors of negative 6 that give me negative 1. So that's negative 3 and positive 2. And take each of my factors and set them equal to 0. 6 cannot be 0. X equals 3 and x equals negative 2. So that means that my critical numbers for this function are negative 2 and positive 3. Now, negative 2 and positive 3 are going to separate my function into 3 separate intervals. So if I'm looking at a number line, or if I'm looking at the x-axis, I have 3 separate intervals here. I have this interval here, which is negative infinity to negative 2. I have this interval here, which is negative 2 to 3. And I have this interval here, which is 3 to infinity. So I'm going to use those 3 intervals to test the value of the first derivative. Okay, so I'm going to use negative 10 in this interval. So I'm not using a calculator. It's a pretty easy number to evaluate. Okay, so when I evaluate negative 10, this becomes positive. So this is 600. This becomes positive. So I know for sure that this value is positive, and that's all that I care about. Because it's positive, I know that my function is going to be increasing on this interval. All right, now I'll pick a number in this interval, negative 2 to 3. An easy number to use is 0. This whole thing becomes a negative value. That's all that I care about, because then I know on that interval, the function is decreasing because the slope is negative. All right, and then I'm also going to evaluate positive 10. Again, because I'm not using a calculator, it's a pretty easy number to multiply. I have 600 minus 60 minus 36. Again, I know this is a positive number. So because it's positive, the function is going to be increasing because the slope is positive. All right, so I know that because I go from a positive slope to a negative slope at x equals negative 2, I have to have a relative maximum. And because it goes from negative to positive at x equals 3, I have to have a relative minimum. And now I could find those actual points by plugging back into the original function. So if I evaluate on the original function, f of 2, this is the original function again. When I plug in negative 2, I'm going to get negative 2. I'm going to get 58. So that means that I have a relative maximum at negative 2, comma, 58. Okay, now I'm going to plug in 3 into the original function. So I'm going to evaluate f of 3. So 2 times 3 to the third minus 3 times 3 squared minus 36 times 3 plus 14. Okay, and when I evaluate that, I get f of 3 equals negative 67. So I know that I have a relative minimum at 3, comma, negative 60, bear with me, 7. And that's how I find my relative extrema.